The next is stereochemical aspects of nucleophilic substitution reaction. So we know that the normal light, if normal light is chosen, it can vibrate in many directions, or we can say it can vibrate in many planes. Now, if the normal light which can vibrate in different directions or different planes, if it is passed through a polarizer like a Nicol prism, if a light will be generated from a light source, it can vibrate in different planes or different directions. If it is passed through a polarizer like a Nicol prism, this light which was having vibrations in different directions or different planes, when it is passed through a Nicol prism or any polarizer, this light will tend to vibrate in only one plane or one direction. Okay, or we can say that we will obtain unidirectional light when it is passed through Nicol prism, and this light which vibrate in single plane is called plane polarized light. Plane polarized light, which can be abbreviated as PPL. Okay, now if this plane polarized light is passed through a substance, if that substance is able to rotate that plane polarized light either to left or to right, then such substances can be called optically active. Okay, now if we are passing this plane polarized light through a substance and the substance is not able to rotate this light either to right or left, such substances will be called optically inactive. So when we can call a substance as optically active? If we pass plane polarized light through a substance, and if the substance is able to rotate either the light to left or to right, it can be called optically active, or else it will be optically inactive. Now, if the compound is able to rotate the plane polarized light towards right, it is called dextrorotatory compound. And if it rotates the plane polarized light to left, it will be levorotatory compound. So what is optically active compound? What is dextrorotatory compound? What is levorotatory compound? Okay, optically active compound means that substance or that compound will be able to rotate the plane polarized light either to right or to left. If the compound is able to rotate the plane polarized light to right, it is called a dextrorotatory. If it is able to rotate this plane polarized light into left, it is called a levorotatory. So we can say like rotation to right means it is clockwise direction. It is called dextro form. It can be represented as D form or plus form. If it is left, if the rotation is to left, it is either anti-clockwise, it can be called a levorotatory, L form or minus form. Okay, so the D and L form of a compound, combinedly called optical isomers, and this process is called optical isomerism. What is optical isomers? If a substance is able to rotate the light to right, PPL to right, it is dextrorotatory compound, and if it is having like levorotatory also, if it is able to rotate the light to left also, it is called a levorotatory. So they combinedly called optical isomers, and the process is optical isomerism. The next is chiral or achiral molecules. Chiral and achiral molecules. So if the mirror image of a compound is same as the compound itself, if consider this A, if you take the alphabet A and place in front of a mirror, you will get the mirror image as same. Okay, mirror images will be same, and if the mirror image and the substance are same, will they be superimposable? No, right? Will they be superimposable? Yeah, they will be superimposable. If the mirror image and the object are same, they will be superimposable. If they are superimposable, they are called achiral. Okay, so achiral molecules does not show optical isomerism. Okay, That means they are not able to, achiral molecules or achiral compounds will not be able to rotate a plane polarized light to either left or right. Now what is achiral molecules? If the mirror image of a substance is superimposable to each other. Okay, superimposable to each other, they are called achiral, and thus they will be optically inactive. They will be optically inactive and they cannot show optical isomerism. Now if a compound and its mirror images are non-superimposable, like P, if you place the alphabet P in front of a mirror, the mirror image will be like this. So if you try to place this P on this, will they be same? No, they will be non-superimposable. We can't place both of them as same. If you place this P on the other, they will not be the same. That is non-superimposable. So if they are non-superimposable, they are called chiral molecules and they will show optical isomerism. They will rotate the light, plane polarized light, either to left or to right. Now if all the 4 valencies of a carbon atoms are satisfied by 4 different groups, if we know that for carbon there are 4 valencies, if all those 4 valencies are satisfied by different groups, such molecules will be non-superimposable to their mirror images and they will be chiral molecules. So if that all 4 valencies of carbon are satisfied by different atoms or groups, that compound will be chiral molecule and they will show optical isomerism, and this property is called chirality. Chirality means all 4 valencies of carbon are satisfied by different atoms or groups. Okay, that property of carbon is called, or that compound is called chirality. So if there is chirality, optical isomerism will be shown. Now what is enantiomers? The stereoisomers related to each other as non-superimposable mirror images are called enantiomers. So that is D and L forms. They are non-superimposable mirror images. Is it? If one of the enantiomer is dextrorotatory and the other will be levorotatory, and they will be dextrorotatory and levorotatory combinedly can be called as enantiomers. They were called as optical isomers, is it? And they can be called as enantiomers. So consider these two. They are chiral molecules and they are non-superimposable mirror images. So if we pass plane polarized light to this mirror image, and if it rotates the light, plane polarized light to left, we can call it as levorotatory compound. And here we have said that if one of the enantiomer is dextrorotatory, the other will be levorotatory. So here if it is levo, now if you pass a plane polarized light to this, it will rotate the light to right, so it will be dextrorotatory, and these two will be what? Enantiomers. Now the next is racemic mixture. A mixture containing D and L form. What is D form and L form? It is dextrorotatory and levorotatory. A mixture containing D and L form of a compound in equal proportion. Okay, so the substance will rotate the PPL to right to some extent and to left to the same extent, that is equal proportion, and thus they will have zero optical rotation. Okay, and this is due to what? Here the rotation due to one isomer is cancelled by the rotation due to other isomer, since one is to, the rotation is to left, the other is to right. So if they are in equal rotations or equal extent or equal proportion, that will be, rotation will be cancelled by each other. Okay, and thus they will have zero optical rotation, and such mixtures are called racemic mixture or racemic modification. The process of conversion of an enantiomer into a racemic mixture is called racemization. What is enantiomer? Enantiomers are what? Are the stereoisomers related with each other as non-superimposable mirror images. Okay, so that is, if one enantiomer rotates the PPL to left, the other will be rotating it to right. So what is racemic mixture? The mixture containing D and L form in equal proportion, and thus they will have zero optical rotation. So the process of conversion of those enantiomers into racemic mixture is called a racemization. Okay, so this much is about the stereochemical aspects of nucleophilic substitution reaction.